This section will be discussing issues around contact area on the build plate. So another issue that you might come across in 3D printing is an issue surrounding contact area with the build plate. So what is this? What is this issue? Sometimes if you have an example, the chair on the right, and you want to print it vertically or in a certain orientation, you might end up with a very small contact area with the build plate. Let's actually go into SpaceClaim and try to design this. Get rid of our previous design. We'll enter Sketch. Let's build a simple model of a chair over here. Or we can go back to our model of the table. Just for ease of reference. Okay, so just a quick model of a table or a stool or a chair. Let's imagine that you want to build this along the Z direction with the feet being at the base on the build plate. So what would happen obviously is the only contact area that you have with the build plate is the combined surface area on the bottom of the legs or on the feet. Considering this, you'd only start off on the first layer just with a few circles over here and here. And as you start going up and building this area, you'd have a really long cylinder with a very narrow area in contact with the build plate. And just through basic physics, the longer the line away from the point of contact, the larger the force would be if you go from the side. So if you have your 3D printer build head and FDM and it sort of touches or gives a lateral force onto this leg over here on the top, the torque or the moment that would be experienced on the bottom of the leg would be force times direction away from the rotational point. And as you go up, the direction increases. And so using the formula with the multiplication, it will end up being a much larger force. How can we overcome this? Well, you could increase the surface area in contact with the build plate by adding a brim. Yeah, so you have more surface area in contact with the build plate. If we go over here, we've discussed how it can be detached from the build plate because of the tiny surface area. We've mentioned brims, and this is one of the more common tools, apart from clever orientation, because obviously if we built it from the top down, where the top of the table or the stool is in contact with the build plate, and we build it pretty much upside down in this orientation, then we have all of the surface area in the contact with the build plate, and that's a more clever solution. But obviously, if we had a chair and it had some poles or the backrest coming out to here, it'd be more difficult to orientate it that way. So that's sort of an example that we're covering here. This is using the brims. Yeah. So what actually is brim? A brim is an extension of the surface area on the perimeter of the base that's in contact with the build area to provide a better bond. So if you look over here, how we had the image of the chair, if we extend the surface area of the legs or of the feet that are in contact with the build plate, you'll have a better first layer or base layer adhesion. Where can we find this tool? As with most 3D modeling tools in Ansys SpaceClaim, it's in the pull, in the pull edit option. We go left into the ribbon with under the general tab where we had the add and the cut and the round and the chamfer tools. We have an extrude edge tool. Because right now, if we click and drag, we're using the chamfer or the round tool, yeah, the fillet tool, yeah. And then if we chose chamfer, we'd be using the chamfer. So let's select the extrude edge tool. And what this does is actually it gives us two yellow arrows over here, one vertically down and one horizontally. If we click and drag the horizontal arrow, you can see how it extrudes the horizontally the edge that we chose along the perimeter of the feet. Yeah, but this pretty much gives us just a surface area. It's not exactly 3D. So when we send this model to a 3D printer, it would have an issue because it won't be able to detect it. This area has technically a 0 thickness, which obviously kind of makes sense mathematically because we're working in 2D rather than 3D when we're discussing this. But in a real life application, the 3D printer needs to know what thickness of the layer to target. So for us to add the thickness to this, we just click the up arrow and this extrudes the surface area up. Well, actually that just extrudes the perimeter, creates another surface area. So technically this is not the case. What we need to do is, please forgive me, use the pull tool, but just select the actual surface of the thing, yeah. Right. Previously, what we had selected was just the perimeter, so it only extruded the perimeter, whereas now we're actually extruding the whole surface area. So now we've created, as you can see, a little plate or a little area of contact for the build plate between the model and the build plate. Yeah? And this would provide us better adhesion. Now, if the model is knocked at this area, all of the surface area in contact will resist that motion rather than the small area of contact that we had originally. This is what is called the brim and is commonly used in 3D printing applications to combat poor layer adhesion between the model and the build plate. Now, obviously, you'd think to yourself, well, you could have just drawn some geometry over here and extruded that. However, this can also work on more complicated geometry, not just circles. If this were a zigzag pattern around, it would extrude the zigzag pattern out. You know, and also considering that you'd save a bit on material. You'd also provide an equal layer of adhesion, you know, equidistant from all the points over here on the layer, because let's say we only, if we did a sketch like just on top of here, yeah, let's say we did a square like this and extruded it, yeah, just randomly. A square, yeah, you'd say, oh, that's much easier to draw rather going into the perimeter tool and extruding that. Well, that is true. However, this is not efficient, yeah, as a brim, for the sole reason of over here, the distance from the center or from the edge is much larger than this distance from here and the edge. So the weak point will actually be the distance from here to here, yeah. This distance that I'm drawing now is much shorter, is 2 millimeters rather than this distance, which is 4 millimeters. So the defining distance or the end distance, yeah, that's actually effective. You only have 2 millimeters of effective length around the perimeter of this circle. So all of this additional material that you deposit in the layer over here won't do anything, won't do nothing. It won't actually give it any additional support in this area, only along this edge. So geometrically it's not efficient, it's not standard, and that's why the edge pull tool, yeah, the extrude edge tool gives a much more efficient design, and it's why it's important to know. Obviously, some of this capability is also available in 3D printing slicing software. So if you don't if your design doesn't incorporate an element of brim in it at the design stage, don't worry about it. You can do it in the 3D CAD preparation stage when you prepare it for 3D printing.